Greeting all. Welcome back to another topic for technical drawing. For this week number 5, we're going to be looking on 2 topics. The first one is dimensioning, rule of dimensioning for both projection. The one that we finished last week, orthographic projection, and for the one that will be after these, the calling isometric projection. All right? It's very important to follow the regulation of dimensioning after you complete any orthographic projection drawing or any isometric, oblique, or pictorial projection drawing. It is important to follow the rule that we're going to be looking on in the following 30 minutes in order to achieve a proper dimension of the particular drawing that we are doing. Beginning for dimensioning, depending unit that you are using, the one that we are using most now is in millimeter, right? All dimension up to 1 meter must be expressed in millimeter. It is not recommended to dimension the drawing if the measurement is 1000 millimeter. It's not recommended to place here 1 meter or 1 m. No, you need to have in mind that 1 meter is equal 1000 millimeter. 1 centimeter is equal 10 millimeter. Whatever measurement that you see or you measure any object that is in centimeter or meter, you have to convert that unit into millimeter, just multiplying by 10. If you measure an object that measures 5 centimeter, you have to multiply by 10, and you're going to dimension on the drawing 50. You're gonna write 50 right here over the dimension line. Do not place 5 cm, 5 centimeter, not technically accepted. One more thing, you're not supposed to, not recommended to place stated millimeter in the drawing. The recommendation is at the title block, when you create the title block in the lower part of the drawing paper, you write in there unit, and this unit you are specifying there millimeter or imperial or inches or feet, depend what unit are you using. When you place that information at the title block, unit, and you say millimeter, then when you start dimensioning the drawing, you don't need to be placing again 100 mm, 40 mm, 5 mm, 12 mm. Not necessary, because the title block already say that all measurements are in millimeter, all right, or in the particular unit that are you doing. The only case that you're going to place a letter beside the number is when the measurement is greater than 1 meter, or greater than 2 meters, greater than 3 meters. For example, here, all right, if you have to express 1 meter, because it's up to 1 meter, you multiply by 10, and you write in the measure on the drawing, you say 1000. But if you have to express 1 meter, 35 centimeter, and 9 millimeter in the drawing, you multiply these, that is in centimeter, by 10. That is 350 millimeter. This meter is a 1000 because it's greater than 1 meter. You're going to remain as a 1, right? And then you said 350 millimeter, that is equal to 35 centimeter, plus 9 millimeter. It's equal is 350 plus 9, 359, right? 300 and 350 millimeter and 9, 359 millimeter, right? What you do, you express 359. When you're going to dimension the drawing, what you're going to say, you say 1.359, 359 millimeter. Then when you put it on the drawing here, right? When you place it on the drawing, you support to say it in here 1.359, and then you place the letter meter. The letter, you place the letter M indicating meter, right? Dimension, see another case here. Dimension above 1 meter must be expressed as merely at meter and decimal fraction of meter. Those that is 1 meter, 47 centimeter, and 6 millimeter, you multiply 47 by 10, and it's a 470 millimeter. Plus 6, 476 millimeter. And when you express the measurement right here above the dimension line, what you're going to express 1 meter, 0.476 meter. That's when you express the letter M in there. When the measurement is greater than 1 meter, 2 meter, 3 meter, 4 meter. If the measurement is below 1 meter, you only express the value of the measurement, and that's it. And it specifies on the title block what unit you're going to do it, and you don't have to be placed in millimeter, millimeter, and millimeter. All right? When you have to represent meter or millimeter, it's recommended to use a common letter, right? Right? Don't use uppercase letter. It's just a lowercase letter in this way. Do not use capital letter, right? If all dimensions are in millimeter, is added to the drawing. In this volume, all dimensions are in millimeter except where designated otherwise. All measurements have to be placed in millimeter, not necessary to express beside the number. Only is on a special case that the measurement is above 1 meter or above 2 meter. In this particular case, you're going to place the letter M beside the number. All right, that's the first information that you need to keep in consideration. All right, resume. All measurements have to be expressed in millimeter. When the measurement is lower than 1 meter, it's not necessary to express the unit, the millimeter, MN beside the number. When the measurement is greater than 1 meter, 2 meter, 3 meter, you need to express the particular meter, point, and the remaining millimeter in there. If it's in centimeter, you multiply by 10, and this is the value that you're going to place after the corresponding part of the meter, and then at the end, you place the letter M, indicating that the measurement is meter in there. All right, no capital letter, uppercase letter, or letter must be in lowercase value. For the rule of dimensioning, right? Rule of dimensioning, I'm going to go quickly to this. This line that are here is a projection line or extension line. Projection line or extension line that normally you're going to place it from the particular end of the drawing to the other end that you want to express the measurement of the object. The projection line from this side to this other side. The projection line, make sure that never touch the drawing outline. You have to leave a little gap between 1 to 1.5 to 2 millimeter. Never touch the drawing with the projection or extension line. Extension line have to be right at 180 degree respect to the edge of the object that you're going to draw. Right? Have to be in line, see it? Straight line, like a continuation of this, but you need to have a little gap to indicate that this line is not part of the drawing. When we draw it approximately. If it's only one dimension that's going to be placed, draw it approximately 12 millimeter tall, right? Approximately 12 millimeter far from the drawing in order to create a space in here, right? If more than one dimension going to be placed at the same extension line, recommended to draw it approximately 24-25 millimeter in order to place the first measurement at 10 millimeter far from the drawing, and then the other another 10 from the drawing. Right? You leave a 10 millimeter from here to here, leave another 10 millimeter from here to here. Or you can say 12 from here to here, 12 from here to here, 13 from here to here, 13 from here to here. The important is that the measurement that you use from here to here, trying to maintain the same distance that you use from here to here, maintain the same distance from here to here. Nothing in this drawing that is not like this. This space here is smaller than this space here. When you do your drawing, trying to maintain the same distance. If you use a 13 millimeter from here to here, 10 or 12, use the same 13, 12, or 12, 10 or 12, or 13 from here to here. It's up to you. But keep the same distance that you use in this, keep the same distance for the rest of the dimension you're going to place in your drawing. That is for the projection or extension line. The dimension line now, it's this one that carries the text value of the dimension. This is the dimension line. As the extension line and dimension line, the two of them is a continuous thin line, fine line, continuous fine or continuous thin line, right? Thinner than the outline of the object. The object is thicker. These two lines are thin line. The dimension line always going to be placed parallel respect to the edge of the object that you are drawing. If this is the side of the object that we are dimensioning, the dimension line have to be parallel to this line. Meaning, if you use a 20 millimeter from here to here, have to be the same 20 millimeter from here to here. Parallel line respect to this. The projection, the dimension line will be draw approximately 1.5 to 2 millimeter, all right, below to the end of the projection line, leaving these a little tail at the end of the extension line. Never place the dimension line at the end of the extension line here, forming 90 degrees. No, you need to leave these a little small part of the line at the top that we call in the tail of the dimensioning. Right? Leave this space approximately 1.5 to 2 millimeter space here. Right? Keep the dimension line be touching with arrow, with an arrow, the extension line. You're going to draw an arrow in there, close shaded arrow touching the extension line in both ends. Recommended. Right? Do not leave the arrow open at the end. Just keep it closed. It's most standard use close. Important for the arrow is that make sure that the arrow that we use be isosceles triangle, meaning the two sides, upper and lower, is longer size at equal distance, and the back who close the arrow be a smaller size. If you use a 3 millimeter, the length of the arrow, down and up, you use approximately 1 and 1.5 on the back here to close the arrow. Then you shade the arrow. Don't leave it in white color. You shade it, and it's recommended, standard, technically recommended to do it in that way. All right, that is for the dimension line. Now for the text value. For the text value. The text value of the dimension is recommended to place it at the center of the dimension line, right? And the center here, under the middle of the dimension line, and most time as possible, right? This is the center for this, this is the center for this. You don't try to accommodate this 40 below here to try to look at them pretty, because you break the rules. These 40 have to remain on the middle or the center of the dimension line. This 100 have to be right here at the center of this dimension line. The center meaning right, splitting the line in two approximately, you put it in the center here. You don't have to be dimensioning where exactly you have to put it. By eyes, approximately, you calculate where is the center, and then you place the dimension line. You place the value, the text value right in there at the center of the line. One more rule is the text value, put it at all the time, be read it from this size, all right, calling the left side of the screen from where we are looking, left side of the screen, reading to the right side, all right? The textbook will tell you be reading from right side to left, because is the drawing it places and reverse in front to us. But when from where we are looking, observing the drawing, make sure that the text value reading from left side to the right side. Another important thing, look at the little space between the text value and the dimension line. Make sure that the text number never touch the dimension line. Never touch the dimension line. That's a 3. Number 4, the size that you use for the text value is say you use a 7 millimeter high, right? 7 millimeter high for this. You have to maintain the same height for the rest of them, same size for the rest of them, right? Maintain the same size for them. You're not supposed to have this number big and this number smaller in size. All of them have to maintain the same size. That is for the text value. When is in horizontal position above the drawing, or when it's below the drawing but in horizontal position. When it's in vertical position, like this too, the text value remain at the center or at the middle of the dimension line, reading from below to the top, from bottom to the top, and do not touching the dimension line, and make sure to have the same size than the other test value. All right, than the other test value. These are for the text information. I can add one more thing, that when the text value can't fit inside a particular detail of the drawing, because too small or might confuse the drawing, like this particular case. In this particular, you are required or you are recommended to place the text value outside. It's allowed to do it also, right? It's recommended to put it outside. Also, when the arrow, with the 2 arrows, that should be inside the area to determine the distance. If they're going to be almost clashing or touching one arrow to another arrow, for clear understanding of the dimension, we're going to place the arrowhead outside to the particular area that I want to dimension. See the case here, see the case in here now. Right? For clarity, we put the arrowhead outside, different than this, that is inside, 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 like this. Look at this particular case here. To avoid to put an arrow in here, you can put a this dot, or you can put a little thick diagonal line across. Right? You can put it. This is when you have a continuous, measurement in the same axis. It's not recommended to put an arrow in all of these space. You can just put a thick line across, diagonal, like a diagonal line across, or like a point in there. Meaning that the dimension is from here to the point, from here to the point, from here to the point. All right? That is for rectangular. For rectangular dimension, the most standard rule that we have to take in consideration for our drawing this week. These are for linear measurement. A little note here, linear dimension should be placed as shown above, depending upon the space available. Dimension should not be crowded together. They should be read from the bottom or from the right hand of the size of the paper, right? From the right hand of the size of the paper. When the dimension is angular dimension, right? For angular dimensions, right? We're going to place on a curved line, not a straight line, curved line, and we're going to place the value of the angle, and then we're gonna put that this little 0 at the top of the number, indicating that this is degree. How many degrees are in the particular angle? It's a 30 degree, 15 degree, 45 degrees, 60 degree, 90 degree. We place the value and the same thing, put it on the center, never touch the dimension line. All right, never touch the dimension line, reading from the right side of the paper to the left side of the paper. When the dimension is down in the lower corner of the object, you're going to place the curved line, the two arrows touching, the two rate of line forming the angle, and then the text value going to be inside. Right? The text value going to be inside the particular angle that you are dimensioning. In both cases, I place it inside. The difference is when the angle is below, the text is inside, place it below to that. When the angle is above, right, the arrow, the line is the touching the same angle form, and the text is placed above the dimension line. And this is the position that the number will be placed, depending on where this arc line will be placed, depend the position of the drawing. This is the most important for sloping this type of dimensioning. For radius, all right, for radius, when the dimension is a different style of how we place the radius, recommended to use arc and the value of the radius when the line is open like this. It's not recommended to use radius for any particular circle. When you draw in a circle, recommended to use diameter. When you draw in an arc forming a radius on the particular object, we recommend to use arc, right? Indicating radius. Different form can be touching radius arc, touching radius arc, from center of the R to this, put in R, see another style. Any one of these style can be used for dimension R in here. This is an exemption here where you are dimensioning some square object in order to avoid confusion with some flat object. Recommended to put this as square in front to the value or the text value. These are square representing that when you look at the end view of this object, what you see is that's a square shape. If no square is in front to the value, it might be talking about something flat, something sheet metal, right? Something that is not as square. When the object is square, recommended to place these symbol or sign in front in order to specify that the front part of this is a square shape. For the screw thread for threading purpose, we're not going to be drawing threading no more, putting that the regular shape of the thread like a zigzag line. We're not going to represent zigzag line anymore in order to express that it's a thread. Right? For threading, we're going to place another line below to the outline of the particular bolt or screw. Put this line inside, and it's going to be representing threading. Right? Threading. And depending the unit that the thread had been created, right? If it's a metric system thread, we're going to put a letter M in front. The letter M meaning that the thread belongs to the metric system. All right, metric system that the thread are in millimeter. The pitch that are in there, that the distance between one crest or one thread to another thread will be in millimeter. Depend the type of diameter of the screw, we're going to have a sign and a standard pitch for each diameter of the screw or the bolt in metric system. For instance, when you look at 12 diameter 12, the pitch is 1.75. Diameter 10, the pitch is 1.5. Right? Diameter 8, the pitch is 1.25. Diameter 6, the pitch is 1. And so on, like this. Each diameter will have a standard pitch. That's why it's not placed beside the number. But in some cases, you might see the letter M indicating metric, the number indicating the diameter of the screw, and letter X, that is time, and one number after that. This number that coming after that will be the pitch thread for this particular screw. Right? That is when it's in a, when you represent the thread in a side view, you represent it line like this. When the thread is in front view, you put the circle, and then you put another one and break, right? You break this line. Don't let it close, right? Because if you leave these two concentric circle, close it here, it now represents a screw. It represents it like this is a hollow, a hole, or it's a pipe. You have to be open, right? Open somewhere here to indicate that these are a solid bar with thread on it. If it's closed here, it's like a pipe with a hole on it, or any solid cylinder object with hole on it, right? Be careful with that information. Very important. Dimensioning circle recommended to be in diameter. And the symbol that we're going to be using for diameter is this one that you are looking here, right? You always, when you're going to express the diameter of any circle, you're going to place the symbol first and then the value of the diameter, right? Remember this. Diameter, place always the symbol in here. And the different way you can dimension diameter, putting arrow passing through to the center of the circle, touching the circle and touching the circle. Also, you can use arrow, right? Putting a line passing through to the center and then arrow upside here pointing the circle, touching the circle and expressing their diameter, right? Just review as a recap for all things said so far. Arrow touching must be touch extension line. Arrow must be touch extension line. You have to leave a small extension when you're touching the extension line, small extension here. The overall dimension have to be outside to the smaller dimension. Overall dimension, larger dimension, all the way outside to the smaller dimension. Maintain the same distance that you use for first dimension, keep the same distance to the second dimension. Make sure that the projection line do not touch the dimension line. Make sure that the text value reading from bottom to the top or from below to up, the text value do not touch the dimension line. Place it as much as possible in the center of the dimension line. Radius, different start of radius, touching the particular radius detail, and then you place the letter R and the value for the particular radius. All right, leave a small gap between the two drawing, leave a small gap, and maintain space well for clarity between the two dimensions. Right, space well between the two dimensions. These are what you have to take in consideration when you do the dimensioning for the orthographic projection or for isometric or pictorial projection, right? This is a rule, same rule for both for type of projection. In fact, number in resume here, the dimension, the number, the rule in case you don't remember them, right? In case you don't remember, you have a number 1, number 2, number 3, number 4, all right, number 5, number 6, 7, 8, 9, and 10. 9, 8, 9, and 10. All right. The instruction for each one of the rule are down here. For number 1, dimensioning line, thin full line, place outside the component wherever possible, and a space where away from the outline. The longer dimension line are placed outside to the shorter one, separate by 10 millimeter, not a standard 10. You can use 12, you can use 13, 14, it's up to you. It depends the size of the drawing, you're going to determine it. If the drawing is smaller, I recommend that you use about 10. As soon as the drawing are increasing the size, you can increase the space between the dimension line. It can be increased to 15 to 16 when the number is bigger for clarity purpose. The projection line or extension line is a thin full line which extends from the view to the provided boundary for the dimensioning line, normally drawn at 90 degrees to the outline and the dimension line. The arrowhead draw with a sharp stroke which must be touched the extension line. The leader line is a thin full line which is drawn from a node dimension or in case a balloon and terminate in an arrow or dot. The leader line, this is called a leader line, right? These line pointing here is a leader line. This is pointing leader line. This leader line, leader line. These are say leader A, this leader line, this is A leader line. Those lines that we use to specify any particular information the drawing is called in a leader line. All right, that is the let me just because for some reason the some of the rule doesn't show. Right, it's supposed to be 9 rule. It's showing less. Right, one more left. Okay, now we have all of them now. Stop a leader line, relatively small gap. Number 5, the gap that are between the drawing and the projection line. Approximately 1, in information here coming 1 millimeter, can get a 1.5 to 2 millimeter is a good distance in order to get a better clarity in here. The little gap, do not touch the drawing with the projection line. Number 6, the tail, approximately 2 millimeter, same 1.5 to 2 millimeter from the dimension line to the top of the projection line. If from the arrow to the top of the projection line, leave approximately 1.5 to 2 millimeter. The crossing extension line usually break to ensure clarity. Let me write here. Where you have 2 extension line, this is an extension line, and this is another extension line. In case that you have 2 extension lines that are crossing like this, right? Crossing like this, recommended to break one of them, right? Break, leave a space right here. You erase the sides and erase the sides, and don't let the 2 lines to intersect at a point. Okay, confuse. If they intersect here, it look like another box here for the drawing, right? It look another detail here, the particular drawing. This is like a gap here, and this gap here, plus the intersection break here will give you a clarity of the drawing, specifying that this is a drawing and this part is not part of the drawing. Also, notice that all the lines here are the same thickness. This should not be done too. The line representing the drawing should be thicker, right, than the line that are using for dimensioning and for extension or for leader line in order to get a better clarity of the drawing. Number 7, crossing, I say that, crossing. Number 8, dimension generally should be placed near to the middle, near as much as possible in the middle, slightly above and clear of the dimension line. They might be placed to the right or left of the middle to avoid conjunction. In those particular cases that the text value might be clashed or might be confused in the drawing, you have a choice to place it near to the left. You can place it near to the right. In case that it might be confused with some other detail of the drawing, you can move that dimension a little to the left, move it to the right. If it's not, just keep it as most of the time at the center of the dimension line. The number 9, dimension line, dimension placed so that it might be read from bottom to the top. Reading from lower up. Never place the dimension that you have to read it from up down. Dimension number 10, placed so that it might be read from right hand size of the drawing at the drawing sheet, right? Place it, that can be, this is the right hand of the paper when you put it on at the drawing board. This would be the right hand of the paper, right? This is from where we're looking, is our left side, but we have to follow where the drawing had been drew. That is, this is the left, right? Right hand of the paper, and this is the left hand of the paper. And place the text that can be read all the time from right hand to the left. or from bottom to the top. These are, in case I don't remember the rule, these are stating clear everything that had been mentioned today for this. Right? This is the rule of dimensioning that you have to keep it in consideration when you are dimensioning the drawing. All right. These are the drawing that we're going to be doing this week in order to practice the dimension, right? In order to practice the dimension, the orthographic projection dimensioning, and to practice the oblique dimensioning, and to practice the isometric projection dimension. Meaning with these two drawings, we're going to be able to practice when we are doing orthographic projection front end and plan view. We're going to be dimensioning like this, right? This is for 3 examples of orthographic projection in dimensioning when it's in horizontal and vertical position. This right here is an example that we're going to be looking when we are drawing in oblique projection. That's going to be explaining in the next class. These examples are oblique projection in dimensioning. And here is an example of isometric projection dimension. In the next class, I'm going to be explaining that is isometry because I have a 30 degree and 30 degree. And this is oblique projection because you have a one side remain on the horizontal plane and another side remain and move on a 45 degree in any one to the right or any one to the left. It's a decision to the person who are doing the drawing, right? That is a text coming for the next tutorial class that is also for this particular week too, right? First video now is just for the rule of dimensioning. Now I'm going to record another video for the rule of isometric projection and pictorial and oblique projection. Isometric projection and oblique projection. We're gonna look now this particular another video after this. Please watch the next video in order to get a full information how to get through to the isometric and oblique projection. All right, that's all for now. Make sure to watch the video and good luck.